What do you consider to be advanced Python? Well, that's up to you. But today, I'm going to show you 6 advanced Python tips you can get started with today that are better going to optimize your code and productivity. Welcome back, guys, to another episode of, you guessed it, Code with Josh. And for obvious reasons, that's me. I'm going to put these 6 advanced topics somewhere on the screen, right? Maybe here, I don't know, okay? But these are the 6 topics we're going to talk about today. And guys, I have timestamps, okay? If you know some of these, that's okay. Look at the bottom, okay? I have timestamps. Skip along to the topic that you need to learn, all right? And guys, before I jump into today's video, do me a favor and click the like button, all right? Like and subscribe, as that helps me as a small channel grow and reach more students around the world, all right? If you learn anything today, that's all I ask. All right, smash the like button and let's dive into the episode. Now, today's episode might be a little bit longer, but it's jam-packed with good information. How I've done this for you is I've created material that breaks it all down, all right? And then once I introduce that, we can jump into VS Code and implement that, all right? Guys, you can get my handcrafted Python and Get Starter Pack absolutely free. It's the first link in the description below. Head on down there and get your copy of this Python guide to help you get started in your Python journey. All right, let's head over into our first advanced tip of the day. All right, the first one up, we're going to talk about our dictionary comprehensions. Now, how each of these is broken down is I've created this example. It's basically like a story of how I tried to break it down to explain what each of these advanced topics is. Now, guys, comprehensions, it's just like list comprehensions. And if you missed that video, I'm going to link it somewhere here. That was a popular video. That's when I broke down and went through how a comprehension works. A dictionary comprehension is the same thing. Check that video out. Okay, so imagine we have a list of names and we want to make a dictionary. Okay, so the key is going to be a name, and then the value is going to be the length of that name. All right, so traditionally, right, when we're learning how to code, this is what our code would look like. I have a list, I create a dictionary, a for loop to go through an iterable, a list, and then I can add that as the value in my dictionary. Right? That works, that's true, but your code is not as optimized, it's not as efficient as a comprehension. To use a comprehension, I create a new dictionary, curly braces, just like we normally do. The first thing that goes in there is going to be my key value pair. What's going to represent the key, and then what's going to be the value. Then I need an iterable. I need to go through something that I'm going to add to this new dictionary. So you can see that I'm going through our list of names. And every name that's in my list, every name is the key. And then the value is the length of that name. So literally the output is the same thing, right? Alice 5, Bob 3. Whatever that name is, Josh, the value is going to be the length, 4. That's how we could create a dictionary comprehension. Okay, wait, all right? That's new. Pause the video, all right? I'm going to take you over now into VS Code. Let's implement a dictionary comprehension. All right, so here's our first example of dictionary comprehensions. Now, I've chosen football. Guys, football's cool. I don't know as much about it as you guys, so I'm sure some of these players may have changed teams by now. Don't judge. Sorry. Okay? I have 2 lists. I have players and I have clubs. And I want to create a dictionary, and I want the player to match the club. The player is the key, the club is the value. So I can loop through, and we're using zip, right? Zip shouldn't be too new. It allows me to zip 2 lists, 2 iterables together, and essentially create a dictionary from that. So players will match each value in clubs. Then I'm going to take my dictionary, adding the key and the value, right? So zip itself isn't making the dictionary. It's just matching together 2 lists. So every value or every elements match each other, right? And then we print off the player to club. If I run my code... Wait, real quick, guys. If you're still here, it means you like this stuff. So come on, help me out. Click the like button, you know you want to, and subscribe for Python content. Here is your dictionary created. Now, this is the traditional route, right? But let's make a dictionary comprehension. So I'm actually going to turn all this off. I don't want that. I'm going to keep my lists. That doesn't change. Let's create like player Here's my player to club. It's the same thing, but I'm going to create a comprehension, so our curly braces. And my key is going to be the player, and then my value is going to be the club, right? Straightforward. Now I need to loop through, and I'm going to say for every player and club in my zip. Okay, what are we zipping together? Well, my players list, I'm zipping up with our clubs. That's the same line, that's it. Okay, well then all you have to do is come down here and we're just gonna print off, once again, player to club. Run your code, and we have the same output. So now instead of doing that in 3 lines, we've smushed it down to a single line. That's dictionary comprehensions. So as you approach your code and you're working through projects, I want you to think about how can you refactor your code to implement these advanced tips that we're going through today. Guys, if you enjoy content like this, do me a favor, click the like button and smash the subscribe button. That really helps me grow. And comment below which one of these tips is your favorite, all right? As going forward, I'm probably gonna create a video around each of these advanced topics to go through and break it down even more. But today, it's kind of just all in one. Like, subscribe, comment, which one's your favorite? Now that we've talked about comprehensions, let's jump in and let's go talk about generators. That's right, what is a generator? All right, next up in our advanced tips are generators. Have you used a generator before? All right, this is a new topic, it's quite advanced as well. I want you to think of a generator as a list, but instead of storing those hard-coded values, it doesn't store the value for long memory. It uses it once and it moves on to the next one. So this is great for when you're not wanting to store so much memory and you want your code to run faster and more efficient, we can create a generator. So here's my example for this one. Imagine we have a big list of numbers, but we only want to look at one number at a time. So a generator can let us do that without having to use up all of our computer's memory. Okay, so imagine you have a list of 100 numbers. If you print that list, it's going to print all 100 numbers. But I don't want to see all at that same time. I can only use one at one time. Right? That's how our brain processes. I read one thing and then I move to the next. Well, a generator is almost like a delay. It's giving you time to process that one element, that one piece of information, and then move on to the next. Cool. We can make a generator with a function, and we use the yield keyword here. This is a new keyword probably if you haven't used generators. Every time you ask for the next item in our list, our generator, it gives you it one by one without storing them all at once. So this is how you would traditionally do that, right? I create a function, okay, I loop through, and I add all these numbers to a list, right? But when I return this, I'm going to return a list that has all these values in there, right? That's just a list. But let's convert that to a generator. So a generator, we create a function that still takes a number. I'm going to loop through, and every time I loop through, I am yielding I. So just think of yield as like return. I'm going to return I. Once I return I, I'm going to proceed to return the next value. Right? That's actually what yield does. So every time the for loop runs, it's returning I, and then it's deleting I. It's resetting and going back to its original state. Outside my function, I can create a variable, calling my generator function, giving it a number, right? And then because my generator is like a list, I can use a for loop to go through it. And I can loop through my generator. So instead of printing a list of 1, 2, 3, 4, 5, my generator is only giving me one number at once. 1, 2, 3, 4, 5. Pretty cool. All right, let's take it over into VS Code and let's code out some generators. All right, let me just keep on the topic of sports, all right? I've created a function called generate jersey numbers. Now, I don't want this because I want to make a generator function, right? Let's watch the output. What's going to happen when I run this code? Well, you can see that I'm returning a list of numbers, so ideally, I should just get a list of numbers from 1 to 11, which I do, right? But that is using up a lot of computer's memory. That's why we use a generator. A generator is just like a list, but but we use the element once and then we just move on. That's it. Let's refactor our code. So closing this out, let me turn off, well, pretty much everything. The only thing that I'm going to keep is the name, right? Because I mean, I can keep that. That doesn't change. I still want to do that. Generate jersey numbers, but this is going to become a generator. Now what I'm going to do is I'm going to loop through and I'm going to say for every number in the range. Okay, great. What's my range, right? So just like last time, it needs a start and it needs an end. We're adding 1 because Python starts on 0. Now that I've gone through every time this loop runs, what do I want to do? Well, remember, a generator reveals one at a time. So I want to reveal. It's like return, but then continue on. So instead of saying return, I'm going to say yield. What do I want to yield? The number back. That's our generator, pretty much done. I can go up here and I'm just going to collect this line of code, right? The same thing, right? Jersey numbers, okay, I'm calling our function. So what's the value of jersey numbers? Is it a list? No, it's a generator, right? So it's kind of like a list, but it's a generator. Now I can loop through this because a generator is also an iterable. So let's just say for I in jersey numbers, let's print off I. Now let's watch what happens when we run our code. Boom. You can see that it's giving me a number 1 at a time and then moving on to the next after returning to its original state. That's how we can use a generator function to save memory in Python. That's incredible. All right, I'm going to close this out here. Now you're getting a fairly advanced understanding. Let's move into a new topic of decorators or decorations. Next up in our advanced topics is decorators. Now, decorators are really cool. And it's just like the English word decoration or decorator. Imagine it like a tag that's linked to a function. And if the function has this tag, you can change the behaviors of this function while still keeping its original state. So it's like adding extra things onto it. That's really cool. Let's check out my example. Imagine that we have a plain cake. That's a boring birthday. But we want to add some frosting and other decorations to make it fancier. Decorator, decorations. Decorators let us do that to our functions, right? So what we need to do is first we have to create a decorator function itself. And we do this by using the @ keyword, right? It's just like an email, @ that creates a decorator for us. This is going to add an extra step before or even after the original function runs, which is really cool, right? So a decorator is just like a Christmas tree. You get a tree, and that's your function, right? And then you add decorations onto the Christmas tree. Those decorations are your decorators. It's us altering the original state of the tree, but at the end of the day, it's still a tree. So over here, I create a function called addDecorator that is going to take a function. This function is your decorator function. You can call it anything. Elephant, applesauce, airplane. I don't really care. Okay, but choose something you're going to remember. Inside there, we pretty much just nest another function. So I have a function inside of a function, and it's called wrapper. When wrapper runs, it's going to print before the function, and then it calls this. What is func? Well, that's the function we passed in to our decorator. It's going to run this function, and then it's going to print off something else, closing out our function. Okay, so Python knows this is a decorator because it's a function in a function. That's how we know. Okay, you can call your decorator anything. Now, when you want to use the decorator, for example, before some function, I can use the @ symbol and I can put my decorator name, so @addDecorator. Then we call a normal function. To run our program, we just call the outer function, so say hello. Say hello is really this function here. Python is going to print before the function, hello world, after the function when we run our say hello function. That's exactly how a decorator can work. All right, let's go decorate VS Code with some decorators. I'm going to see you there. All right, let's change up our story a little bit. We're going to introduce how to make a decorator in Python. You can see that I have the average stock price. Well, let's run it. It's just going to calculate the average. That's all that's happening here, but just to show you. Boom, you can see the average stock price is $110. All right, let's create a decorator and kind of like wrap this and do other things with just this calc function. So I can pretty much, well, let's just turn everything off. I don't really want anything anymore. I do want my list. So I'm gonna keep the list. If you're still here, it must mean you like this stuff. So do me a favor, help me out. Click the like button and subscribe. All right, back to the video. I'm gonna come down here and I'm gonna create a decorator function. Let's just say message decorator. Cool, that's a function. Now remember that a decorator also takes another function. So what function is gonna be passed to it? We don't know. I'm gonna say func. Inside there, we are gonna create our wrapper. This wrapper is gonna take any argument that the initial function, so calc average, would have taken. So we're gonna wrap that because it's gonna be passed to the function still. Initially, I'm going to print off some stuff, and I could say something like calculating the average stock price, ... It's doing something. And then I want to call my function, so I can create that because my function's going to return something. It's returning to me the average. I'm going to store that in a variable, res, calling my function, which is now called func, but that's really the average function. So inside here, what do we want to put? Well, I want to put my prices. Once we get that value, then I'm going to print off something, and we can say, well, just like what we said before, let's go up here and take this. Let's say the average stock price is something, okay? Now, I don't have average, that's fine. I'm just going to change that to res, that's our response. And then once we're done, I'm going to return the wrapper itself. That's the wrapper function. Whoa, that's amazing. I can take this function still, Control X, come down here, paste it, let's turn it back on because we still want to use it. It's just I want to do things before and after I use it. That's why we're wrapping it in a decorator. So we have this calc average function, right? Now if I go down here still and I do exactly what you're thinking of, I'm going to like print off, let's just print off calc average prices, and inside there I can say prices or stock prices. That's the thing. Stock prices. Okay, cool. Run the code. It literally just gives you a number, 110, because you're just calling the calc average function. I want to call the decorator first, so let's add the decorator. In order to get that to work, what we're going to do is I'm going to come here and I'm just going to say at, and then what's the name of your decorator? Message decorator. This is going to be called first, and this wrapper, this decorator, is going to use our calc average price function. I don't need to print anymore because our decorator is printing for us. I just need to run the code. Look at that. Calculating the average stock price, that's triggering line 9, and then the average stock price is 110. That's triggering after we get a response from res. That's great. So that's why we create decorators, to decorate ordinary functions. And now you know how to get started with them. Try and implement those in your code. Can you refactor some of your code for that? Let's find out. It's time to move on to our next topic of context managers. Our next advanced topic is quite advanced. It's context managers. Now, a context manager is basically like a little helper, right? Like an elf. They make sure that you use your resources and your files the correct intended way. They manage tasks, essentially, right? So my example here, imagine we're borrowing a toy from your friend. Now, I mean, if you're old like me, you're not borrowing a toy, but you get the point. You say that you're going to give it back later, and when you're done, you make sure that you return it. Okay, well, that's a context manager's job. A context manager helps you to remember to give it back when you're done. That's its job. Now, we're going to introduce two new special methods that usually you've probably just seen these type of dunder methods when working with classes. Well, we're going to make a class here. But now enter and exit, we want to do this when we enter the manager. And then when we're ready to exit, we're going to do something else. That's what these dunder methods do. When you use the with keyword, it sets up the resource for you, and when you're done, exit will automatically clean it for you. So I create a class called, toy manager. And then we create our enter method. So when we enter the manager, it's going to print taking the toy, and then it returns this value. And then when we're ready to exit, it's going to print returning the toy. Now this class is not going to run, right? And so I'm going to say with my class as my object toy, I'm going to print playing with toy. What's going to happen? Well, it's going to enter the manager. So it's going to say taking the toy, and then it's going to say playing with toy, and then it's going to exit the manager. So it's going to say returning the toy. That's how we set up a context manager to help us manage our resources, making sure we achieve what we're looking for in Python. Let's jump into VS Code and let's implement a context manager. So here we have a traditional try and accept handling statement, but I'm using finally, right? We want to try to open this document. I want to write something inside, and then I'm going to close this document. And you can see here that I have a text file that's empty. If we run the code, it is going to work how it should. It ran, check your document, okay, boom. Quarterly business report, it's working. I'm going to delete that to clear that up, save that, trash your terminal, go back. Now, a context manager, its job is to manage when you're not there. Right? That's what a manager does. Okay, so you can go work on something else and your manager is going to oversee or facilitate this area of your file. That's why we create a context manager. We could add other things in there as well and have it do multiple things. Let's convert this to a context manager. So I'm going to turn this off just like I have been doing. No need, no point. I'm going to create a class because that is our context manager. Let's just call this report manager. That's what their job is going to be doing. Inside here, what do we want to do when we enter our manager? Okay, so I'm going to tap in self. That's all we need for enter. So I'm going to create a file, and with this file, I would like to try to open it. Okay, so inside open, we can just drop in what you originally had, which is like your file, and then what do you want to do? Read, write, append, or edit. I want to write in this file. Great. I can now return my file. If it's been opened, that's great. It's now prepared to be written inside of. I'm going to return it to write it. Okay, so I've entered my manager. Is my manager done, or what do I want my manager to do when they are done? So now I need to give it a few things. It's going to take self, but a context manager actually takes 3 other arguments or parameters as well, even though you won't really give them a value. Those are execution type, execution value, and a traceback. Drop those in. We don't have to worry about those too much, okay? What do I want my manager to do when we exit? Well, it's going to take my file, and it's going to close my file. Now that I have my manager done, I want to use my manager because it's basically my employee. So let's put it to work. Let's literally say with my employee or with report manager, and I'm going to refer to the manager as the file. What do I want the manager to do? I want him or her to write. Okay, what do I want them to write? Well, that's up to you. I'm just going to go take this, what we originally had here. I can drop that here, and then we just run the code. If you check your file, it worked the same way. You can see I have text in that file, right? So now you know how to create a context manager to manage your tasks in Python. All right, our next topic is called unpacking. Let's check that out. No, it's not unpacking your suitcase, all right? Imagine I have a list of like 10 items, and in the list, I want to assign each element to a variable. That's unpacking. So in our example here, unpacking is just like sharing candies from a big bag with all your friends. You take each candy out and you give one to each friend. So everyone gets their share. It's just like unpacking. We need enough variables to match the values. You unpack values from containers. So a container is pretty much any iterable. Not any, okay, but a lot of them. So lists, tuples, dictionaries, strings. So let's take a look here at the first one. If I want to unpack a list, I have a list of numbers, okay? I take my list as the value to variables, right? So because I have 3 variables, 1, 2, 2, 3, 3, they match to each element in the list. Now I can just print off my variable and it's going to output that value. This also works for tuples the same exact way, right? If I take my tuple as the value, 1, 2, I make sure that each of those 2 has a corresponding variable to hold the tuple value. This is so much faster, and we're doing it in one line. That's unpacking. Now let me show you a dictionary really quickly. So a dictionary is kind of the same, but remember that a dictionary has key-value pairs. So really I have 2. Which one do I want to be the value to my variable? That's for you to decide. It could be the key, could be the value. Outside here I have name and age, and then I take my dictionary getting the values, right? So I'm taking Alice and 12 as my variable values. Print name, output a string of Alice. That is amazing, okay? Now let me take you over into VS Code and let's unpack some things there. Let's check it out. All right, so here you can see I have a tuple of stock info. And I picked Apple. I don't actually own Apple, but it's popular stock, right? So remember, unpacking is taking each element out of an iterable and assigning it to a variable in one line of code. Traditionally, this is how we do this. I have my tuple, and then I create 3 variables, and I assign those values. I can use those out here, right? If you run your code, it's gonna work exactly how you'd expect it. There you go, stock name Apple, current price, previous closing price. But these 3 lines, we don't need those, right? That's taking up too much space. It's not optimizing your code efficiently. Let's unpack those. Closing out, I can turn off these lines. They're not really needed. I can come down here. Now I have 3 elements in my tuple, so I need to create 3 variables. I can say stock name, just like before, current price, and lastly, previous closing price. I have 3 variables. Now they need a value. This value must match the elements in my tuple, so stock info, right? The value of my 3 variables is stock info. So Apple is the value to stock name. You run your code, we see the same output. Go. Now, unpacking doesn't just work for tuples. List, tuple, string, dictionary. We can unpack a lot of things in Python. Try to optimize your code to unpack here now. All right, that's great. Guys, this takes us into our last advanced tip. And this last tip, speaking of an iterable, is a named tuple. Josh, what the heck is a named tuple? Let me show you. This brings us to our final one, which is named tuples. Named tuples are like special containers that not only hold things, but also label things. Now, the way that I like to view it, okay, is a named tuple is like an object. Okay, usually an object's value is a class, but this time it's a tuple. But it works the same way. So this named tuple is an object, and it just holds data, right? So imagine you make a class that its only purpose is to hold a user's name, age, and email. But the class doesn't do anything. Then why are you making a class? It's really just storing data. You should be using a named tuple. Let's check it out. So here in my example, right, imagine we have a box where you keep your toys, a toy box. Each toy has its own spot with a name tag. Named tuples are like the box. It's just holding data, right? There's no methods that you're adding or anything like that. It's literally just an object that holds data. Pretty cool. So it's essentially like creating an object on the fly. We can use these objects later. And more specifically, right, if I give it like a name, a size, a color, it's just like a class. A class has properties, and I can access and edit these properties later. Well, a named tuple, an object, it's the same thing. So here, in order to get named tuple, I need to import it from the collections module. Then I'm pretty much creating a class, right? Now it's not a class, but remember, it's capitalized. So just think about a class. I'm creating a class, which is really a named tuple, and this class is going to be called person. This person is going to have 3 properties: name, age, and city. Currently there's no value, but there will be. Now that I've created this named tuple, this object, this class, I'm going to create an object, and I want to use that class. Now I have my class, I'm going to give it my 3 arguments, or the value to those 3 properties. It works the same way. Now I can tap into each of those properties, and I can get those values. This is how you can quickly create data on the fly with named tuples. That is amazing. Look at that. All right, let's head over to VS Code and make you some named tuples. So here I'm just going to carry on with the same tuple, stock info, okay? Because we're talking about a named tuple. If I want to return these values, I could do just that, right? I can do this, print them off, and you're going to see the values. Okay, great. Now look at that. I have the values. But when I start to have a bunch of stocks, it's going to get a bit repetitive. It's not organized. This is just holding data. So I'm going to create a class, an object, or a named tuple to do this for me. Okay, let's edit all this. So I'm really just going to turn it all off. In order to get named tuple, I need to tap into the collections module, and we're going to import named tuple. That's an extra additive to Python. I'm now essentially going to create a class. I want you to think of it like a class because it kind of is. I'm going to call this stock. Notice how it's capitalized. Stock is going to be a named tuple. What is the name of this tuple? Well, I've already given it a name actually, stock, okay? And then what are the properties or the values in here going to be? Well, okay, it's going to be a name, it's going to be a current price, and it's going to be a previous closing price. All right, there we go. So I now have a class, a stock class, named tuple, that has 3 properties that I can assign to it. Let's come down here and let's create now stock info. All right, so stock info is like an object. What's the class? Well, stock. It's not really a class, it's a named tuple. Inside here, it even tells me. I'm going to say name equals. Okay, what's the name? Apple. That's just what we had before. Okay, great. What is the current price? Well, the current price can be $150.25. And then finally, what's the previous closing price? What do we have? $149.50. That's the same thing. This is done in one line. This is much more easier to read. I could even rename this to be more specific now because I could have more stocks like Apple info. If you come down here, I'm going to actually take all of these prints and I'm just going to drop them here. And let's just turn them back on. Okay, I don't want stock info anymore because it's not really anything. I want to take my object and I want to tap into the name property, right? So it works just like a class, even though it's not. Let me add the others. There we go, let's run our code. And we have the same output with the name tuple. That's how we can condense our data and make more effective storing of this data in our Python code. Well done, guys. That is your name tuple with all the same relevant information as your final advanced tip. That's awesome, guys. Those are your 6 advanced tips in Python. Guys, think of all this material. This took me a lot of time to put together, and I want to make education absolutely free. Do me a favor, like this video, help me out in the YouTube algorithm, as well as subscribe if you're not, as I have free Python content coming out to help you grow every single day. And when I hit 1,000 subscribers, I'm thinking of doing a giveaway with you guys. So do me a favor, hit that like button if you enjoyed today's content. You now know these 6 advanced Python tips, and I challenge you to go in your code, try and refactor some game you have or some app you have, and implement these 6 strategies. And remember, guys, you can get my handcrafted Python and Get Starter pack absolutely free. It's the first link in the description below. Head on down there and get your copy of my handcrafted Python guide today. If you're looking for a bit more guidance, you can get my courses down there. Check them out. All right, it's up to you. All right. But that was our topic for today, guys. I'm super stoked and I'm glad to have you here. I can't wait to see you guys in next week's episode of Code with Josh. Until then.